In this video we will talk about levels of implementing an algorithm or a computer program. If you have an algorithm like this, which is an example from my previous video, you can implement this algorithm as a script in a scripting language. You can implement it as a source code for the virtual machine. You can implement it as a source code, or you can implement it in assembly, or you can implement it in hardware. If you implement your code as a script, that means that your code will be run by an interpreter. Some of the interpreted languages are Python, Perl, Ruby. JavaScript is interpreted language. Now Shell Script and Batch, they are command line interpreters, but you still can write code in these. MATLAB is also interpreted fully fledged language, but it's only used for plotting Cartesian graphs or polar graphs. If you choose to implement your code as a source code for a virtual machine, that means you will be using languages like Java or languages like C#. Java compiles to bytecode and C# compiles to MS Intermediate language. Both bytecode and MS Intermediate language are virtual machine codes, and they need an interpreter to run. This interpreter may or may not use just-in-time compiler to compile virtual machine code into native code. If you implement your code as a source code for a compiled language, you will be using languages like C, C++, or Go, and your code will be compiled to native code, which means it should run fast. Examples of software that are compiled to native code are drivers, game engines, other interpreters, operating systems, and other compilers. This is all because native code is fast. Assembly code is also compiled to native code, but you have much more control over the machine you are using. Some of the examples of architectures that are in use today are Intel x86, x64 architecture that is used in all your desktop computers. ARM is used in all your cell phones. MIPS, Atmel AVR, and Microchip PIC are used in microcontrollers. Examples for software written in assembly code are codecs, like video codecs, audio codecs, or still image codecs. The last and fastest option is to implement your code in hardware. To implement your code in hardware, you may use hardware description language like VHDL or Verilog, or you may draw a schematic. So what kind of code or functionality you can implement in hardware? For example, some microcontrollers don't even have multiplication implemented in hardware. Big processors like Intel CPUs add things like AES instructions for hardware accelerated encryption. Graphic cards have hardware for calculating functions like 1/x², sine, cosine. Video and audio codecs, or essential operations for video and audio codecs like discrete cosine transform, can also be implemented in hardware. And these can be implemented either in graphics cards or CPUs. If you like my video, please like, subscribe, and thank you for watching.